Yes, hi everyone. Today we will revise functions. So question number 1, define using mathematical terms, including sketch. So after you answer the question, don't forget to draw a sketch. So a function. What is a function? A function is a relation in which no two different ordered pairs have the same x coordinates. So let's write it down. So after writing the definition, we need to sketch the graph. So the function will look something like this, but definitely this one is not a function. Not a function. Okay, so not this one. These two are the function. So this is a little sketch for functions. B, a turning point. So the turning point is a point when graph change from increasing to decreasing or vice versa. If I will sketch the turning point, like on this graph going down, so it's decreasing, then it turns and goes up, it becomes increase. So this point is calling the turning point. Also it can be vice versa. This is the graph is increasing, then it goes down, it's decreasing. So this point and this point are turning points. So let's write the definition for them. So the turning points we also can define our maximum or minimum points on a curve. In our case, on our sketches, this is a minimum point, this is a maximum point. So turning point is a maximum or minimum point on the curve. Next question, points on inflection. So the definition for points of inflection is a point where the curve changed from concave to convex. So if I will sketch it, I will have, let's say, I have graph like that. So I've got concave here. It's concave, and from this part it's going convex. So the point, this middle point, it's called point of inflection. Let's write down the definition. So the definition is when graph changes the shape from concave to convex or vice versa. So this question done. Let's move to another one. Question number 2. Determine which of the following are functions. In each case, give a reason for your answers. So it's definitely the first one is function. Why it's a function? Because for each value of x, there is only one value of y. Normally, to check it, we can draw our vertical lines, and we'll see the intercept with the graph. We've got only 1 point here, 1 point here, 1 point here. So the vertical lines intercepting only once. That why this is a function. And let's write the definition. Let's look on a second picture. It's definitely not a function. So it's not a function. Because for each value of x, there is more than one value of y. We can check it by drawing the vertical lines. So look, the vertical line intercepts twice with a graph. Another one, it's again 2 point of interception. So this one is definitely not a function. And let's write down the definition of that, the explanation of that, sorry. Yeah, so first one is function and the second one is not a function. And let's move to question number 3. So next question, I've got three functions, f of x, g of x, and h of x, and I need to find out f of minus 2 in the simplest form, so I need to do all simplification. F of minus 2, that means I will use my function f of x, and for x I will plug up number minus 2. So it will be 1 minus 4 times by minus 2, which will give me 1 plus 8, and the answer is 9. Next one is f of 0. Now for x, here I will plug in 0. It will be 1 minus 4 times 0, and the answer is just 1. Next one is f of 2x plus 1. So for x now, I will plug all that big bracket. I will have 1 minus 4, and now for x I will write all this bracket, 2x plus 1. And the answer will be just simple algebra, open the brackets, it will be 1 minus 8x minus 4, and the answer is minus 8x minus 3. Then they ask me to find out g of 0. In this case, I will use my g function. And for x, I will just write down 0. So I've got 0 plus 3 square. And it will give me 3 square, which is just 9. And the last one here is to find out the g of 2x minus 1. Again, I will use my g function. Now for x, I will write all this big bracket. So it will be 2x minus 1 plus 3 and all that square. Just simplification in the brackets, it will be 2x plus 2 and all that square. And what I will use here, the perfect square. So it's 4x square plus 8x plus 4. Okay, and just for a reminder, I will write you down the formula for a perfect square. If it's a plus b squared, it's a squared plus 2ab plus b squared. And if it's a minus b squared, so it will be a squared minus 2ab plus b squared. Next question is to find out h f of x. I will write down my function h of x and f of x here, so I can use them. Okay, here is my functions. Now I need to find out h f of x. So h function, I will use this function, and for value of x, I will write down my f of x function. So just using the simple steps, it will be h f of x equals 2, and for x I can write down f of x. And now just f of x, I will use the function. I have 2, 1 minus 4x, just opening the bracket, I will have 2 minus 8x. So next question, it's a big one, f of g of h of x. Okay, so I will start with my function f. Okay, I've got 1 minus 4, and for x I will write all that thing, which is g h of x. Now for g function, I will use g function, And for x, I will write h of x. So I've got 1 minus 4, and then I've got my g function, which is x plus 3. So, and for x, I am writing h of x. It's h of x plus 3 and all that square. And then just plugging h of x, this number, I will have 1 minus 4, 2x plus 3 squared. Now just opening the brackets and simplifying, but first what I will do, the perfect square again. So I will do that perfect square first. I've got 1 minus 4, and a perfect square will give me 4x squared plus 12x plus 9. Then just opening brackets, I will have 1 minus 16x squared minus 48x minus 36. And just the common terms, simplifying, I will get minus 16x squared minus 48x minus 35. Question number 4. For each of the following graphs, draw a sign diagram. So for first one, I will draw my line. And here I will just write these x-intercepts number. So it's minus 1 and 4. Now, as I see here, my function is positive. Also here is my function positive. So it's plus and plus here. And on this part, it's under the 0, so it's negative. My sign diagram is ready. Let's do the same thing for the second function. So here's the x-intercept. It's only 1.2. And what's happening? On this side, my function is negative. Also on this side, my function negative. So it will be minus and minus. And function number 3. Now I've got point minus 3. And I've got point 1. Now, here is my function negative. So it's negative here. And then all here my function is positive. Also after my function is positive as well. So it will be minus plus plus. Question done. Next questions. I've got two functions, and for each of them I need to find out the domain and range, the interval of x where the graph is increasing and decreasing, the interval of x where the graph is concave up, which is convex, and concave down. So let's start with domain and with our first function. So domain is x values. So x values here for my function, x can be anything. The function is continuous, so x values, it can be anything. That means I will write down just domain it's x values, and here x can be anything, so it's element of R. It's element of any rational number. Range, it's y values. Let's see on y. Can it be 4? No, my function is not defined here. Can it be 3? No. So the maximum value, what can be y, this is their maximum, it's value 2. And everything down. So my y have to be less or equal to this is my range. Now, let's find out where my graph is increase and where my graph is decrease. So, increase. Let's see. My graph increase here, so this part, and on this part. Now let's write down where it's increase. So it's increase when x is smaller than -2. So it's when x is smaller than -2. And also when x is between 0 and 2. So my x have to be between 0 and 2. Now let's find out where my function is decrease. The function is decrease on this interval and also on that interval. Okay, so it's decrease when x value between 0 and -2, so it's x between -2 and 0, and also when x is less than 2, bigger than 2, so when x is bigger than 2. And the last thing I need to find out for this function is where it's concave and where it's convex. So let's find out where it's convex. It's convex. So this is a point of inflection for the function, and as I see, my function is convex in this interval. Convex in this interval. So the x values are between -1 and 1. So x have to be between -1 and 1. And let's see where it's concave. Concave. The function is concave on this interval and concave on this interval. So it's concave when x smaller than -1 and when x is bigger than 1. So we finish with first function. Let's move to the second one. We'll just erase this part and we'll find out all these values for a second function. Now let's investigate the second function. First, about domain. So domain is x values. And because this function is continuing, going everywhere, the x can be any number, so it's element of R. Let's see about y. Again, y continues up and down. That means the range, which is a value, y can be any number as well. Now, let's see where my function increase and where my function decrease. So here is my function increase, it's going up, and also here my function goes up. So by using these points, which is, let's say, it's a little bit unclear here, it's 0, definitely 0 here, and 1.5 here. So it's increase when x is less than -1.5 and when x bigger than 0. and the function increase on this interval. The function increase when x between negative 1.5 and 0. So my x is between negative 1.5 and 0. Now let's see where it's concave and where is convex. Now convex, this is a point of inflection. This point, which is negative 0.5 approximately, is point of inflection. So the function is convex on this interval. So it's convex when x bigger than 0.5, and it's concave on this interval. So it's concave when x is smaller than negative 0.5. Question number 6. Draw sign diagrams for each of these. So when I draw the sign diagrams, I need to find out the x-intercepts. So x-intercepts when my function, which is x minus 4, 2x plus 1, have to be equals 0. And just solving this, I will have x minus 4 equals 0. Two brackets are equal 0 when one of them are equal 0. Or when 2x plus 1 equals 0. Just solving, I've got x equals 4, 2x equals negative 1, x equals half. So I've got my two x-intercepts, which is half or 0.5 and 4. Now I need to investigate the function to see where it's positive or negative. If you've got the graphic calculator, you always can check your answer on that by drawing these quadratics, this function. If not, just use the original function, plug in the number, let's say, which is, sorry, I lost my minus here. Yeah, which is less than half in the function, and let's see, it will be positive or negative. So less than half, let's say minus 10. Minus 10 minus 4 will be, so I plug minus 10 here. It will be minus 10 minus 4 becomes minus 10 minus 4. 2 times minus 10 plus 1. Minus 10 minus 4, it's minus 14. And 2 times minus 10, it's minus 20, plus 1, it's minus 19. Minus times minus, it definitely will give me plus. So plus is here. Just remember, you always can plug these numbers and find out. Now, the number between half and 4, the easiest one is number 0. I will plug it here, so it will be here. It will be 0 minus 4, which is negative 4. 2 times 0 is 0. So negative 4 times 1, it's negative 4. That means this part is minus. And then just plug one number, let's number 10, in this, and you find out that here is positive. My question B. So I've got this function, and to find out x-intercepts, I will make it equal 0. Product equals 0 when one of the brackets is equal 0. So x plus 1 equals 0, or x equals negative 1. Or the next one is x minus 2 equals 0, and x equals 2. So now to draw my line and to find out sign diagram, I just plug this my x-intercepts, which is -1 and 2. And again, by plugging numbers here or by drawing this graph on your graphic calculator, you will find out that this function is negative here, and positive here. Draw a sign diagram and sketch possible graph, okay, for the following function. I've got the function where I've got the fraction. So the function equals 0 when it's, again, I need to find out x-intercept. So the fraction equals 0 when the upper side, the numerator, is equals 0. So I will write down that 3 plus x. Sorry, it's not x. I will try to write it again. So it's 3 plus x, 1 minus 2x have to be equal 0. Here I will find out my x-intercepts. So the same principle, the product equals 0. That means one of the brackets have to be equal 0. So 3 plus x equals 0 and x equals -3. Or 1 minus 2x equals 0, minus 2x equals -1, and x equals half 1/2. So these 2 points, my x-intercepts, I can draw them straight away on a line. It will be -3 and half. But also I know that denominator can't be 0. So the next step, I will find the asymptote of this function. So I know that denominator x plus 1 can't be 0. That means x can't be -1. This is my other point, which is -1, and function not touching, not crossing this point. It's an asymptote. Now the same rule, plug one number which is less than -3, let's say -5, you will find out that this one is positive, this one is negative, this one is positive, and this part is negative. Now let's try to sketch this graph, because they're asking you to sketch a possible graph. So this is my x and y coordinates. Now let's put these points, -3, so graph crossing this point, -1. -1 is asymptote, so function doesn't touch it. And also I've got another point which is half, 1/2 or 0.5. Now let's try to draw my function. So less than 3, it's positive. After that it goes negative, and it's touching, but it's going very close, but don't touching -1. Then I've got the positive function here, which is very close to my asymptote, and then going through the point of interception is half, and then the function becomes negative, so it's going down. This is a possible sketch of my graph. So the last question, number 8. If I've got the function f of x equals ax plus b, I need to find out a and b, and also it says that a and b are constants. What means that they are constants? So they are not variable, they are number. When f of 2 equals 12 and f of 3 equals 17. So first of all, I will find out my function f of 2. f of 2. I will use my function, which is ax plus b, and for value of x, I will put 2. So I've got 2a plus b. So 2a plus b, and also I know that f of 2 is equals 12. So I will write down that this one equals 12. Let's then find out f of 3. Again, I will use my function, and for value of x, I will plug in 3. And I will have 3a plus b equals 17. So I've got my two equations. I've got my first one, 2a plus b equals 12. 3a plus b equals 17. I've got simultaneous equations, and you can use any method to solve them. You can use calculator, you can use method of elimination, and also the method of substitution. Here, because the b's are the same numbers, it's easier to use the elimination method. So what I will do, I will minus these two functions. So I will do first equation minus second equation. So the answer will give me 2a minus 3a, it's minus a. b minus b is 0, so nothing there. 12 minus 17, it's minus 5. Minus a equals minus 5, so a will be equals just 5. I find out my a value. Now to find out the b value, I will substitute that a in any of these equations, in the first one or in the second one, doesn't matter, the answer will be the same. So I will use the first equation. I will have 2. For a, I will write times by 5 plus b equals 12. So it's 10 minus b, plus b equals 12. b equals 12 minus 10, and b equals 2. So I find out my b equals 2. Now I will just do the same by plugging a in a second equation, just to show that the answer will be completely the same. Now I will plug a in a second equation, so it will be 3 times 5 plus b equals 17. 15 plus b equals 17. b equals 17 minus 15, and b equals 2. So I've got the same number, and my answer is a equals 5 and b equals 2. So this is my answer, and we finish the revision of functions. Good luck. Bye-bye.